for all x, which of the following statements is true? F is continuous but not differentiable at 2. I would say it's for sure continuous. There's no values. Usually we'd say has to be greater than 0, but any absolute value is greater than 0. So we're good there. Differentiable. Let's check that. The graph of a square root right 2 should look something like, normal square root looks like this. But if we do the absolute value, it reflects itself. So it looks something like this. So what's happening here is our cusp or our sharp point. So therefore it would be not differentiable at 2. So I think we hopefully found our one right away that's true. Let's check. Differentiable at 2, we just said it wasn't. Not continuous at 2, it is. The limit as x goes to 2 is not equal to 0, well, it is. And vertical asymptote. No vertical asymptotes at all, so it's got to be A. Number 12, using the substitution u equals square root of x is equal to the following. If u equals square root of x, then du equals 1/2 x to the negative 1/2, which also equals 1/2 times 1 over square root of x, which is convenient. Well, let's take a look. Let's do our limit changing. If x is 1, I put the 1 in here. Square root of 1 is 1. If x is 4, I put the 4 in there. Square root of 4 is 2. So my integral is going to be from 1 to 2. Let's talk about undoing this guy right here. If my derivative of u, if my du has a 1/2 in it and I don't have 1/2 here, I need a 2 here. And then real quick, I'll just show the algebra on the original function being e to the root x. Let's pretend it's times 1 over root x. That helps you see that this part right here is e to the u, and this part right here is my du with the 1/2 canceled out front. So that's the reason it's going to be e to the u du. And with the 2 in front from 1 to 2, it's got to be c. There it is. Looking at 13, the function f is defined by, what is the value of the area under the curve from 1 to 5? Let's get a sketch in there. It is 2 when it's less than 3. And it is x minus 1 after 3. So at 3, that would be 2, so they'd meet. And then it'd be look like that, I think, to 5. Let's find some area. 6, good. 2 plus, what's this guy here? Is that just going to be 4? So we've got a little trapezoid there. 2 plus 4 divided by 2 times 2 is 4. So 6 plus 4 is 10. Good. Looking at 14. F of x is x squared minus 4. G of x is 3x minus 2. The derivative of f of g of x at 3 is... I would say a couple ways to do this. I might... Yeah, it's probably easiest just to put this guy in there. So the square root of 3x minus 2 squared minus 4. I might even simplify that first before I started working. So 9x squared minus 12x plus 4 minus 4 is actually going to give me a 0. So that's my function. Let's find its derivative. 1/2 that to the negative 1/2 times the chain rule, 18x minus 12, putting in the value of 3. I don't know, calculator. Nice. 27 minus 36 to the negative 1/2. Not 27, 81. That was confusing me. Times 18 times 3 is 54 minus 12. Let's do some cleaning up. 45 to the negative 1/2 times 42. All right. Well, 1/2 of 42, let's call that 21 over the square root of 45, which still isn't even an option. But one of our algebra properties of simplifying the square root of 45 is 9 times 5, so we can take out the 3. So 21 over 3 root 5, make that a 7. 7 over root 5's got to be my answer. Good. All right. Twice differentiable. Which of the following is true? Love these problems. Very good calculus problems. We've got h prime, and h double prime. So let's find the relationships at 6. H prime of x is f of x. H double prime of x is f prime of x. So now we've got all the relationships. Let's first talk about what h of x is. H of x is the area from 0 to x of the function. So h of 6 would be the area from 0 to 6. Well, that area is negative, so that is less than 0. H prime is f of x. F of 6 is 0. H double prime is f prime, so it is the slope of f. The slope of f through 6 is positive. So there it is. Positive, negative, and a 0. Our smallest one is h. Our largest one is h double prime. I would have guessed A. All right. Looking at 16. We've got someone walking with a position. We know their position. Where are they at rest? Where is their velocity equal 0? So I've got to derive the position. The derivative with respect, change with respect to t. Derivative of t minus a would be 1. Derivative of t minus b would also be 1. Our 2/3 bow tie, t minus a plus t minus b. We want to know when it's at rest. 2t, I'm going to add the a and the b over. T equals a plus b over 2. The funny thing about this one is if you graph this, you can actually see, like using your Algebra 2 skills, where the vertex is, and you would get this answer as well. It's kind of cool. I would totally challenge you to do that. Looking at 17, the figure above shows the graph of f. If f of x is the integral from 0 to 2 of g, so what is f prime? F prime is g. So if this is f, and I want to know what the graph of g looks like, I'm looking for the graph of the derivative of this. So what is the slope of this? Looks like it's a positive constant. The only one that has a positive constant is a. Getting to number 18. I actually put this one on the board for the pre-calc kids when they were doing definition of the derivative, and they said, oh, isn't that just finding the derivative of natural log of x at 0.4? And I said, yes, it is. So we've got a couple options here. We could recognize that that is finding the derivative of the natural log of x at 4, and say the derivative of the natural log of x is 1 over x, which would then be 1 over 4. Another option is actually just to derive using L'Hopital's, because we've got a 0 over a 0. The derivative of the natural log of 4 plus h is 1 over 4 plus h. The derivative of the natural log of 4 is 0. And the derivative of h is 1. So again, now I can put the 0 in for h and get 1 over 4 over 1, That would also get me there using L'Hopital's. The function f is defined by f of x equals x over x plus 2. On what points does a graph have the property that the line is tangent to? So when we say tangent, we got to do derivative. When we say derivative, we've got to say quotient rule. When we say quotient rule, we say low, d high minus high, d low over low squared. And we want to know, when is its slope 1/2. It's actually not too bad to solve. I've got x plus 2 minus x, which is actually just 2 over x plus 2 equal to 1/2. And if I cross multiply, I get 4 equals x plus 2. So x equals... I was confused there for a second. We do get 2 over x plus 2 squared equals to 1/2. So we get 4 equals x plus 2 squared. Now if we take the square root of both sides, we get x plus 2 equals plus or minus 2. So either x equals 2 x equals 0 or negative 4. Which the only ones there has got to be C, x equals 0 and negative 4.